Hello, grade 10s. I just wanted to make a little review note here. Our chapter is based off of two big concepts here, expanding and factoring. Okay, so all of these here are quadratic equations, expressions, because we've got no equal sign anywhere here. So we want to be able to expand them, but we also want to be able to factor them. So here, everything is fully expanded. If we're factoring, we're putting it back into brackets. If we're expanding, we're getting rid of the brackets. Okay, so these two are kind of like opposites. So for expanding, we had two different methods. So our first that I want you to learn was our chart method. So I'm going to put 2x and minus 1, and then 3x and 2. And now it's kind of like a multiplication table. So 3x and 2x is going to be 6x squared. 3x and negative 1 is negative 3x. 2x and 2 is 4x. 2 and negative 1 is negative 2. We would put all of this together, and that would be our answer here. So we have 6x squared minus 3x plus 4x minus 2. These two here are like terms. So we have 6x squared plus 1x minus 2, and we're all done. You could have done this using the FOIL method. So our first ones, 2x and 3x, that gave us 6x squared. 2x times 2, there's our 4x. It's just kind of in a reversed order. Negative 1 times 3 is negative 3x. Negative 1 times 2 is negative 2. Okay, so using our FOIL method or our chart method, we end up with this expression here, and then we can put our x terms together and be all done. So that's expanding. Factoring. So we had three types of factoring. Common factoring. Difference of squares factoring, and lastly product and sum. So in this one, I'm not telling you specifically which one you have to use. So we're going to just have to try to identify what we have here. Now, for all four of these, we always want to try to common factor first. Okay? If we can common factor, do it. You'll either be done, or it might lead you to one of these types of factoring. So, common factoring, I can't take a variable out of all three of these terms because our last one doesn't have an x on it. So I can't do that, but I can divide out a number. Looking at this, the only number I can divide out of all three of these would be 3. So I'll have 3x squared, oops, I take my 3 out. So 3 divided by 3 is 1, so I just have x squared. 9 divided by 3 would be 3x, and 12 divided by 3 would be 4. And we can quickly check and see if we did this right by multiplying everything by 3. Now, is there any numbers that add to 3 and multiply to 4? Well, we have 1 times 4 and 2 times 2. None of those add to 3. We're done. This is fully factored. Okay, this kind of looks like one of these ones, but there's actually nothing that works. So no numbers that worked, we're done. This one here, can I common factor an x out? Nope. Can I common factor a number out? Not that I see here. So this one's actually a difference of squares binomial because we have two numbers that we can square root with a minus in the middle. So whenever I notice that, I'm going to set up my two brackets. One's going to have a plus, one's going to have a minus. The square root of 4x squared would be 2x. The square root of 81 is 9. So I have 2x plus 9, 2x minus 9. That's fully factored. We're all done. This one, can I common factor? Nope, there's nothing to common factor. It's not a difference of squares because we have three separate terms. This one might be a product and sum. So product and sum, we had to find two numbers that add to -2, but multiply to -24. So start off with the multiplication portion. So for 24, you can have 1 times 24. You can have 2 times 12. You can have 3 times 8. You can have 4 times 6. 5 doesn't work. Oh, 6 is here. This is our whole set. Okay? Now, if we're going to have to multiply to a negative number, that means that one of these two numbers is going to have to be negative, and it's going to have to add to -2. So if it's adding to -2, they got to be pretty close together, and the bigger one would have to be negative. That's only going to happen here if we make our 6 negative and we have 4 times -6. So 4 plus -6 is -2. 4 times -6 is -24. Once we've done that, we can factor. So we've got x plus 4, x minus 6. So we're just using the numbers that we found there. Last one. Can we common factor? We can't take an x out, but we can take a 4 out because 4 divides out of all three of these. So we have 4. We're going to be left with x squared. 12 divided by 4 is 3. And 16 divided by 4 is 4. So do we have any numbers that multiply to 4 and add to 3? Actually, this one's kind of like this one. So no, nothing multiplies to 4 and adds to 3. So this one's done. Okay, so those two ended up being pretty similar problems there. All right, so hopefully that helps a little bit. Good luck on Friday.